Okay, here is our next, the most easiest solution that you will generally see implemented in your Python, Java libraries in all the modern languages, and that is the idea of a semaphore and also called a mutex. So semaphore is a general term. We will see what mutex is. Now the idea is that you have a data type, an abstract data type already made for you in these languages, just like you have int, you have float, you have double, you have a specific data type which is semaphore, which is used explicitly for achieving such kind of synchronizations that we are talking about. So if I could just reduce this. So if you create a variable of the type semaphore that you can see here in this code, you need to include this library, and after that you can create a variable like this. Now the point is you can do two operations on this variable. One is wait and another is signal. It is, you see, again very much similar to the other abstract data types. As an example, when you write a code for a stack. Stack is a data type, abstract data type, and the two operations you do on this are push and pull, push and pop. Similarly, you have queues and there are specific operations, right? You can do on it enqueue, dequeue and things like that. So similarly, semaphore is an abstract data type and you can do two operations on this. One is wait and another is signal. Right? You can look for the dictionary meaning of semaphore. It was actually, the term came much before computer science. It was a system where people used to talk to each other through signals. They would actually stand on the top of mountains and talk to each other by moving their hands in different ways. So anyways, the point here is, let us see what these operations do. So if you apply a wait operation on this semaphore, this is all it does, right? It again, while this the value of this semaphore is 0, it keeps on waiting. You see, it is very much similar to lock. It is slightly, you see, slightly orthogonal here. In our case, we were saying if lock equals to 1, you wait. You can always change that logic by changing the meaning of zeros and ones. Right? You can always do that. So here is the point is slightly different. It says that if the value of semaphore is 0, you keep on waiting, keep on waiting, keep on waiting. The moment this value increases, you cross this and you decrease the value. But again, the point is you shouldn't write these functions on your own. They are pre-implemented again with the help of test and set instruction underlying it, which is hidden. Right, so you again need not worry about that test and set. You should worry about that for your exams, but when you are actually programming in the real world, you need not worry about that. The point is, when you call a wait operation on this S, both of these will happen in a single shot. Right, again no context switch will happen between this. It will happen as one atomic unit. Similarly, when you are calling signal S, you are increasing the value of S here. It will happen in a single shot. Now again the point is, how do we use this same idea into our code, right? Where should I use wait S, where should I use signal S? Let us see. So this is how you actually implement it in C. You can scroll down this manual. So this is how you can include this library. This is how you can create a variable of type semaphore. You can take a simple so this is the variable name, right? This you can change according to your choice. It is just like int x, right? So this is the data type and this is the variable name, and then instead of having names like wait and signal, the name that you will find in C semaphore library is sem_init. Sem_init simply means that from what do you want to initialize the value of this semaphore, and then you can call the wait operation on this, and as you can see, this is what the wait operation does. It does exactly the same thing as you see here, but it happens in a single shot, and then you can signal. So this is the function that you can use for signal, which increases the semaphore value, and then you can destroy it, right? Now the question is, how do we use it, right, in our code? So let us try to do that. Right, now you see the idea is slightly, you see, you cannot use the same idea as lock here. Why is that? So you will have to again carefully think, what should I put in the entry section, what should I put at the exit section, what should I initialize the semaphore value to be, right? And to help you think towards that, there is another analogy which we can use to understand semaphores. You see, semaphores actually represent a more general scenario. So you assume that you are taking care of a restaurant, right? Or let's say you are taking care of a restaurant, let us say, and this is a newly opened restaurant with limited budget. So a small budget with which you can manage, let's say 10 people, right, inside the restaurant. So again, bringing that to the idea of semaphores. So in that case, you can, so the point is, till 10 people enter the restaurant, all is well. The moment 11th person tries to enter the restaurant, you should say stop. And you can achieve that with the help of semaphore here. You can initialize the value of semaphore. So this is actually the value that you initialize it to. If you are wondering what is this 0 here, right, Google for it, try to figure it out on your own. So here we are initializing the value of semaphore to 1. It can be any value of your choice, right? So if you are implementing it, let's say for a restaurant functionality, you can initialize it to 10. Now what will happen? The initial value of semaphore is 10. Every time a person comes, it checks, right? You call semaphore wait. Semaphore wait, what does it do? It sees if the current value of semaphore is 0, then it asks you to wait, otherwise it simply decreases the value. So the point is, if the current value is 10, that means you have a space for 10 people, right? So the value of s is 10, and if someone wants to come, the value is not 0, they can come. Then a next person comes, so they can come and the value is reduced by 1, that now indicates that you have space for 9 people. And then one more person comes, he can come because still 9 is not equals to 0, s becomes 8. That means now you have a space for 8 people. So what the value of s here is telling you, for how many people or for how many threads do you have a space for, right? So if you initialize s as 10, that means that there is a room or there is a restaurant in which there can be 10 people at a time. Right? Till the time 10 people come, there is no problem, they can go past this boundary, it keeps on reducing, and then the moment it becomes 0, right? If you initialize s as 10, if 10 threads already executed this, the value of s is 0, now any new person comes, they have to wait. Similarly, what does it do? The moment, signal s, the moment anyone leaves the restaurant, you increase the value of semaphore, indicating that again my space is increased by 1, right? So at any time, this semaphore is maintaining the value of how many people can actually be allowed inside the restaurant, how much space is left, you can say. That is a generalized idea. So with this you can actually have, you can decide that I have 10 threads, but maybe I want only 8 of them to be inside the critical section at a time. That is required for certain applications, but let us again talk it simply in the terms of producer and consumer problem over here. So for us in the critical section, there should be only one person at a time. We have room only for one person. So let us see how we can implement this. So let us bring this library to our code, and let me see if I can just copy paste all of this at the same time, maybe. So I'm defining a variable of type semaphore here. I want to keep it simple, so I'm simply going to name it as s instead of my semaphore. And then let us initialize this s. So what is this initialization value going to be? This initialization value is going to be, and you should initialize it inside the main, right? You cannot write a statement outside main or outside any other function. So I'm going to initialize it here. I want only one thread to be in the critical section at a time. There is scope for only one, exactly one. So I'm writing it 1 here. And I am initializing s as this, right? Always be careful, you are passing the address here, and that is what we have initialized it. And this one over here is the wait operation. What this does, if there is a space, it allows you to go inside, otherwise it keeps you waiting. So now I am going to put that over here. You see, now it looks much better. I have got rid of that while loop that is probably encapsulated inside this, right, if that was scary. So what we are simply saying over here is, I'll put S here, right. If the value of S is 1 at a time, that means there is a scope, you can go inside. If producer is already there, then you should wait, right. So you simply call semaphore wait here, right. Now it very much resembles the Ram and Shyam thing that we were trying to do. So before entering the critical section, you should wait. If the other person is there, you should wait, and then once you come out, you should signal, so which is also called a post operation here, and instead of lock equals to 0, I am simply going to say post, that's all, right. And we'll put a similar line for the consumer. So again, no idea of log, we just have this semaphore, and I'm not destroying it. So to be foolproof, you should actually destroy it, but anyways, I feel when the program will end, it will automatically be destroyed. So again, let's run, right. So you see, you get the same result. Luckily there was no error in this code. So you can try this, and if you face any problem while doing this, you can just put it on our WhatsApp group, right. So that is how you can keep on using this semaphore. However, there is a little technical thing here that we should understand, so that is coming up in the next video. So I'll try to make these videos short so that you can watch it in some chunks.